In this video we'll explore surface area. Now surface area is the sum of all the areas that create the outer surface of a three-dimensional shape. Two of the most common ones that we can work with are the rectangular prism and the cylinder. And when we look at this, if you think about where this formula is coming from, the two length times width is because I have a bottom face and a top face that are the same size. The length times height is because I've got the left face and the right face. And the height times the width and times 2 is because I got a front face and a back face. So I'm just finding the area of each rectangle and I'm adding them all together. It just happens that there's two that are exactly the same on each side. When I look at the cylinder, and I've got the 2 pi r, that's because I have a circle on the top and a circle on the bottom. And then the h plus r is because if I actually unfolded how those components come out here. So all my parts there are pretty easy to help me remember. I just need the height and the radius. So if I wanted to actually apply that formula for the surface area of the cylinder with a diameter of 20 inches and a height of 15 inches. So I can label my parts. Now if I think about my formula, I need the radius and the height. So I need to change my diameter to a radius, so that would become 10 inches. Now I'll just plug in the information I have. So 2 times pi times 10 inches times 15 plus 10 inches. So I simplify my parentheses and get 25 inches. And now I'm going to multiply my numerical values and leave pi. So 20 times 25 becomes 500 square inches. So if I want to write it as exact, I would say it's 500 pi square inches. But if I wanted to actually approximate with pi, and I typically use 3.1415, I'd get about 1,571 square inches represents the surface area of the cylinder. Now, it's not always easy to use a formula because the formulas can get quite complex. So one thing that we could use is the concept of the net of a solid. And what you think about is if we take the pattern that makes that shape and lay it out in a two-dimensional space, we can then see what are each of those shapes and find the area of each shape. It's kind of like the idea of peeling away the sides and laying them flat on a surface. So one concept of this is the idea of a square pyramid. Now with a square pyramid, I know I've got a square base. In this case I'm even considered to be a square and right pyramid, hence why I'm given slant height. Because for the formula, if I'm looking at my image here, I can actually have a formula that can help me find the surface area. And that is that the surface area is 1/2 times that slant height over here times the perimeter of the base plus the area of the base. Now that formula makes very little sense to a lot of people. And I can plug in all the parts and I can get that the surface area should be 45 square inches. But what may make more sense is the concept of this net. Now, if I take a think about where my triangles are and I cut down the triangles and lay them flat on a piece of paper around the square, what I can see there is that I have 4 congruent triangles because it is a square and the pyramid was right, and I could just got to find the area of the 4 triangles and the area of my square. Now the information I have though is very helpful because it gives me the base and the height for each of my triangles. So I have base and height of 3 and 6 inches for all 4 of these. And if I look, that also helps me understand the area of my square because it's a 3 by 3. So I find the area of a triangle. I'm going to multiply it by 4 because I have 4 of the exact same triangle, and then I'm going to add on the area of that square. So 4 triangles times 1/2 base times height plus the area of my square. Again, that gives me 45 square inches. So whether I use a formula or whether I can figure out how to split it into the net, I should still end up with the same surface area.